On October 19th, 2017, astronomers in Hawaii stumbled upon something extraordinary. As they scanned the heavens from Mauna Kea's summit, their telescopes picked up a tiny, fast-moving speck, barely visible against the endless backdrop of stars. At first glance, it seemed like just another asteroid or comet, one of countless objects that drift through our solar system. Spotting these cosmic wanderers is routine for astronomers, but this one was different. Its path through our solar system was unlike anything ever recorded. This object wasn't bound to the sun. It was racing along a hyperbolic trajectory, a clear sign it had journeyed from a distant star system far beyond our own. They named it Oumuamua, a Hawaiian word meaning a messenger from afar, arriving first. The name perfectly captured the wonder and intrigue of this unprecedented find. For the first time, we had undeniable evidence that objects from other solar systems could pay us a visit. This discovery forever changed our perspective on the universe. Oumuamua became our tangible link to a place light years away, a cosmic message in a bottle, silently drifting through the vastness of space. It felt as if the universe had handed us a mysterious gift from another world. Its arrival was a revelation. The space between stars, once thought to be empty and still, is actually alive with travelers. Objects making epic journeys across unimaginable distances, sometimes finding their way to us. The excitement of discovery quickly gave way to a mix of confusion and curiosity. Oumuamua's behavior was baffling. It tumbled through space in a strange, unpredictable fashion, defying easy explanation. It didn't have a comet's glowing tail or show any signs of outgassing, yet it wasn't a typical asteroid either. Its shape and motion were unlike anything we'd ever seen. Its incredible speed and unique path made it clear. Oumuamua was just passing through, an interstellar visitor making a brief stop before vanishing back into the cosmic dark, never to return. Our window to study it was short, just a few weeks before it slipped away, lost to the depths of space. The more we observed, the stranger it became. Its brightness shifted rapidly, hinting at a long, thin shape, maybe like a cigar or a pancake, unlike anything in our solar system. Oumuamua shattered our expectations about interstellar objects. It forced scientists to reconsider what other solar systems might be made of. It made us realize just how much we have yet to learn about what's out there, drifting between the stars, waiting to be discovered. The universe proved to be even stranger and more mysterious than we'd ever imagined. Each new discovery only deepens the mystery. This silent visitor opened a new chapter in our cosmic exploration, inspiring fresh questions and a renewed search for interstellar travelers. As Oumuamua slipped away into the darkness, it left us with more questions than answers, a powerful reminder that the universe is full of surprises just waiting to be found. Oumuamua's shape was its first big mystery. When astronomers first detected this strange visitor from beyond our solar system, they were immediately struck by how different it seemed from anything we'd ever seen before. We couldn't see it directly, just a faint, distant point of light, but its brightness changed dramatically as it tumbled through space. This flickering pattern told us that Oumuamua was spinning, and that its shape was far from ordinary. The data suggested it was extremely elongated, maybe 10 times longer than it was wide. Imagine something shaped like a giant cigar, or perhaps a flat pancake. Either way, it was unlike anything we'd ever catalogued before. No known asteroid or comet in our solar system is shaped like this. Most of the objects we've studied are much more compact, with shapes that are either round or irregular, but never this stretched out. Nature usually makes rounder, lumpier objects shaped by countless collisions and the slow pull of gravity over millions of years. So why would a natural object be so stretched out? Was it shaped by some unknown cosmic process? Or could it be a fragment from a much larger body torn apart in a violent event? Its colour was also odd, a reddish hue, similar to some distant solar system objects that have been exposed to cosmic radiation for eons. This suggested it had spent a long time travelling through the harsh environment of interstellar space. In some ways it seemed familiar, sharing traits with known asteroids and comets. But the combination of its extreme shape, unusual colour, and mysterious origin made it truly unique. Unlike anything else we've ever encountered, Oumuamua was both alien and familiar, a cosmic puzzle that challenged everything we thought we knew about space rocks. Its surface hinted at a long, lonely journey through the galaxy, drifting silently between the stars for millions, perhaps even billions of years before finally passing through our solar system. But its shape defied all expectations, leaving scientists with more questions than answers. This was no ordinary rock, it was a messenger from another star system carrying secrets from far beyond our own. Scientists everywhere wondered what could create such a peculiar object. Was it a natural oddity? Or something even stranger? The mystery of Oumuamua had only just begun. Oumuamua's movement was even stranger than its shape. As it travelled through our solar system, its path defied expectations, leaving astronomers both fascinated and perplexed. As it left the sun, it accelerated, faster than gravity alone could explain. This sudden burst of speed was unlike anything we'd seen from a natural object before, raising new questions with every passing day. Normally, comets accelerate like this due to outgassing, when sunlight heats up their icy surfaces and creates a visible tail. But Oumuamua had no visible tail, no shimmering cloud of gas or dust trailing behind it. Powerful telescopes scanned the region, searching for any sign of dust, gas or vapour, anything that could explain the acceleration. But they found nothing at all. It was accelerating like a comet, but looked like an inert rock. This contradiction baffled scientists, challenging everything we thought we knew about how objects move in space. To explain the push, Oumuamua would have needed to lose a lot of mass, just like a comet shedding material. But we saw no evidence of that happening, no debris, no vapour, nothing. The usual suspects, water ice, carbon monoxide, were ruled out. These are the materials that typically drive cometary acceleration, but Oumuamua showed no signs of them. The force was real, measurable and undeniable, but its source was completely invisible. It was as if Oumuamua was being pushed by something we couldn't detect. We were left with a mystery. How could something be pushed by a force we couldn't see or measure directly? The more we looked, the less we understood. None of our standard explanations fit. Every familiar theory was crossed off the list, leaving only questions and speculation. Oumuamua forced us to consider more exotic possibilities, ideas that once seemed far-fetched, like unknown physics or even the possibility of artificial origin. Was it a new kind of object, something never before seen in our solar system, or something else entirely? The possibilities seemed endless. The mystery deepened with every observation, as each new piece of data only added to the puzzle instead of solving it. We had to rethink what we thought we knew about the cosmos and accept that the universe still holds secrets we have yet to uncover. Scientists raced to explain Oumuamua's acceleration without a visible tail. One idea, maybe it was a hydrogen iceberg. Frozen hydrogen sublimates into invisible gas. Clever, but hydrogen icebergs are fragile and unlikely to survive interstellar travel. Another theory, a nitrogen iceberg like a chunk from Pluto's surface. More plausible but still rare and unproven. Or perhaps it was a naked comet outgassing large invisible dust grains or pure water vapour. Each idea tried to fit Oumuamua into our existing understanding, but none felt completely satisfying. Every natural explanation had serious flaws. Oumuamua didn't fit any known category. We were left with a cosmic puzzle. Was it a new type of natural object or something else? The search for answers continued. Years later, scientists reanalyzed Oumuamua's data with fresh eyes. They focused on its tumbling motion, how it spun and wobbled through space. This tumbling revealed clues about its internal structure. The analysis suggested Oumuamua wasn't solid all the way through. Instead, it might be hollow or have a very low-density interior. It behaved more like a shell than a rock. This was a radical departure from previous theories. Natural objects, rocks, icebergs, are usually dense and solid, but Oumuamua's motion hinted at something fundamentally different. How could nature create a hollow object and send it between the stars? The new data forced us to reconsider everything. Oumuamua's mystery had only deepened. We were now dealing with something truly unprecedented. A hollow Oumuamua defies everything we know about natural celestial bodies. Asteroids and comets are dense, not empty shells. Gravity pulls matter together, not into hollow forms. The new data made natural explanations even harder to defend. A hollow iceberg or rock would be too fragile to survive interstellar space. The physics of forming such an object are speculative at best, but a hollow, lightweight object would be easier to push, like a kite in the wind. This could explain Oumuamua's acceleration. Sunlight pressure, not outgassing, was pushing it. Solar radiation pressure is real, but usually only affects very light, thin objects. For a shell like Oumuamua, it could be enough. The hollowness could solve the central mystery of its movement. This was a shocking, paradigm-shifting idea. Oumuamua might be a new class of object, unlike anything we've ever seen. The idea of a hollow Oumuamua has split the scientific community. Some urge caution, noting the data is limited and open to interpretation. Maybe it's not hollow, just oddly structured. Science demands we exhaust all natural explanations first. Perhaps the galaxy is full of strange, fluffy objects we've never seen before. But others argue we must follow the data, even if it leads to uncomfortable places. The hollow shell hypothesis fits all the anomalies. And if nature can't explain it, could it be artificial? Humans build hollow objects all the time. Satellites, solar sails. Could Oumuamua be alien technology? A probe, a solar sail, or debris from another civilization? It's a hypothesis of last resort, but one we can't ignore. The debate is no longer just about rocks and ice. It's about our place in the universe. Oumuamua challenges us to consider the extraordinary. Oumuamua's discovery changed science and our sense of possibility. It taught us to expect the unexpected. The universe is stranger than we imagine. New observatories will soon find more interstellar visitors. Each one is a sample from another solar system, a chance to learn about distant worlds. These objects are cosmic messengers, carrying clues about their origins. The mystery of Oumuamua fuels the search for extraterrestrial life. If it's natural, our galaxy is more diverse than we thought. If it's artificial, we may not be alone. Even the possibility of alien technology demands serious attention. Oumuamua is a symbol of our curiosity and our ignorance. Its story is just beginning. The next visitor could arrive at any time. We must be ready to observe, to analyze, and maybe to answer the universe's oldest questions.